like Seth Green and like that crew. You know what I mean?
So last class, just you guys were all there at one point. Last class we had the XXY versus XYY discussion in biology. Do you remember this? Do you remember what? Yeah, the Klinefelter syndrome and.
Oh yeah.
Oh yeah.
Oh yeah, Holly.
Holly?
I have that
like
disease.
that's
So
a
you're
male with Down
male
syndrome.
with Down syndrome. Oh yes, you're African American male with Down syndrome.
Haters.
That's like me.
Bunch of haters in here.
That was hilarious.
Alright, chalky
Wait,
legs.
what else did she say? She was like,
Have you
She
think
was
about
like, yeah,
this?
that's me.
If you think about this, like every year, Holly has like that one thing that everyone just like always remembers, just like
Wait, what was that other one?
vegetarian.
Vegetarian.
Vegetarian. That's occupation.
It's like, oh.
Okay, advanced math. I gave you guys homework from 56.
Yeah.
Yeah. Let's where am I going? Get some chalk.
Oh no.
That's a good question. Any preguntas or questions? Questions, estudiantes?
Wait, I think I have. What's the
Never learned any languages.
I forgot my computer.
Just forgot to do it completely.
Yeah, 'cause yeah.
Turn them tomorrow.
I can't find it. Oh, there it is. I have number 14.
Number 14.
When I was reading it, I didn't understand how it would be underneath the line, but like above the.
Okay, so we're less than x squared minus 3. The x squared one is the parabola. We're also greater than or equal to the line. You can read out the line. And the picture basically looks like this. There's our parabola that should be dashed, but it's okay for the sake of this discussion. And there's our line. And we have region C. We have region A. We have region B, which is on both sides. And we have region D, which is down here. Now, y is less than x squared minus 3. So when the y's are less than, that means that they're below. Now, watch me, if anybody has been having any trouble with these problems, this is going to be a new technique and you may find it helpful. So go to the first one, and if the y is less than the parabola, we're under the parabola. So here's what I'm going to do. Everywhere under the parabola, I'm going to shade vertically. So that's everywhere that's under the parabola. Kosher? Now, we need everything that's also above the line. So I'm going to take everything above the line and shade horizontally. There will be regions where it will be crosshatched. And where it's crosshatched, it's satisfying both conditions. So in the B region, we were both above the line and below the parabola. Notice that that's below the parabola. Because the parabola is going to go up, 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 and be like somewhere up here, right? So we're still below the parabola. Notice the other crosshatch region is over here. Because again, the parabola is coming like this. And we're below the parabola, but above the line. So when you put that together, that makes B. Did you find that helpful, Skylar, that trick?
Mm-hmm.
Good. That's what I love hearing. I just said that earlier in another math class. When people say that makes sense, that's what math is all about. It's all about sense. Perfect. Any other questions? Going up, going dip, going 12. El Solo.
That's not a number.
When advanced math. And Kramer's is not on here because he forgot to do it.
Okay.
Turn it in tomorrow.
Sure. No biggie.
When I played baseball in high school, one of the guys on the team, his number was 1. And anytime he did anything well, we were like, great job. For 1. Oh, boy.
Well, since we're talking about weird noises,
Yes.
can you do the one weird noise that I really like that you do?
Which one? Like the frisbee games?
Yeah.
Is this
I gotta imagine something happening. Like what?
Oh, okay.
So
Oh my God, Mark! We just won the lottery! Woo! We'll be at home and he'll hear something on the news that he likes. And I'll be in a different room. Woo!
and that comes from in 7th grade on the basketball team. We would have to shoot free throws, and if you missed the free throws, you had to run lines.
I remember that.
So every time somebody made a free throw, because we were studying Spanish at the time, just real basic Spanish, I would say "sí" really loud every time somebody made it, and that just evolved over time into.
So we play Ultimate Frisbee. So, and like the weather guy from one of the weather channels
Jason
plays.
Myers, the really thin guy on 21.
He's on the league and we played against him the whole time. Mark was going, bet you didn't predict that, did ya?
Yeah.
Do you know what's in the forecast today? I'm gonna make it rain.
He'd make a throw. He'd make a throw and then hit the ground instead of hitting his man. And I'd be like, are you supposed to know the wind rate, weatherman? And yeah.
Awesome.
They beat us, by the way. It wasn't awesome. We did not get last time. Although they did say after the game was over, because they thought we were going to be a pushover, they totally thought we were going to push over. They said, you guys were way better than we thought you were going to be. But we still didn't win.
Could've been like,
And even if I wasn't in the game, I'd be screaming this if he was on the other side of the field, missing a throw. I'd be like, predict that weather. And I would guard him too, and he did not like me. But I was comfortable with that. It's okay. Because like we're playing a game, it's competition, and he can be as angry at me as he wants. So it's like, what's gonna happen?
yeah, it's like just fuck up.
If he's thinking about me, he's not thinking about frisbee, and then I win.
You should have seen that guy too. If you sat on
How
him,
did you get into playing Ultimate Frisbee?
he's
College.
great.
College. 7th grade during recess. 7th grade during recess, there was this little strip of road that like went back from like the main lot of the school to the teacher lot, and it was where we had a place where we had recess, and me and Brady Oxender every day threw a frisbee back and forth the entire recess every day on that little, and we'd skip it. We could go under our legs and skip it off the ground. We could go backwards and throw it like that. We could go around like that. We could do all sorts of crazy throws, and
He took
then
me
that
to
evolved.
Concordia one time. I had played a few times before, but not as aggressive. If you've had a bad day, you can really take some anger out. That's fun. Oops, sorry, there goes your tooth.
Right.
You better get that fixed.
Okay, so let's crack the MVs.
Crack a tooth.
Yeah. Krakatoa. do you guys remember Krakatoa? Krakatoa is the largest volcanic eruption in the world. Largest. It was.
It's a crack on your toe.
This was thousands of years ago, and it was actually the beginning of the Dark Ages, and the reason why they call the Dark Ages are because when the Krakatoa volcano exploded, 10,000 times more powerful than Mount St. Helens, and Mount St. Helens was like, it's still in the history books today, right? So Krakatoa, 10,000 times more powerful. It kicked up so much dust and ash that the sun was blocked for days. And the plant life started dying, and people were struggling to stay alive, and there were famines earth-wide. And that started the Dark Ages.
You know, and that's interesting too, because I don't know if you guys are aware, but in the world there are 6 supervolcanoes. And these supervolcanoes, the magma chamber, the caldera underneath the ground, are the size of Texas.
Oh my God.
So if one were to erupt, pretty much the entire United States would be dead, and 1/3 of the population would survive. And because of the ash that billows from the volcano, it would block out the sun for years, and all crops and everything would completely die.
We're talking like dinosaur, like
And this,
extinction.
and one of the super volcanoes, guess where it's at?
Under Old Faithful,
Under Old Faithful
Yosemite.
in Yosemite,
Oh, is that?
Like, and basically, here's
Wyoming.
so basically, let's think of the physics of this. Let's think of the physics of this. So here's the crust, right?
If we all die today, I love you all.
Yeah, right. If we do die today, it's seriously like we're on good terms.
I'm gonna dive into it. You will die. Just like magical.
So here's the solid part, solid from the pressure. Here's the liquid part, liquid from the heat. Here's the crust. This is like the crust on the top of your tomato soup when you let it sit out too long. Because back in the day when Earth was originally formed, it was formed from hot meteorites that were, because a star exploded. A really big star exploded. It's called a supernova. And whenever it exploded, it spewed out all this hot, like, rock. And when hot rock gets near hot rock, gravity pulls it together, and we had this big hot rock that became Earth. This is 4.5 billion years ago. Well, eventually, the sun's only so hot, that rock is not going to stay molten forever. It's going to start to cool, like the crust on the top of the tomato soup when you let it sit out too long. So what we're standing on right now is just cooled down over time molten rock. That's what it is. Now, as the crust cools though, there's like thick spots and thin spots, right? Like when your tomato soup, you like push in one spot and you're like, dang, that's a lot of film. And you push in another spot and you can go right through, right? Same thing with the crust. Okay, so there are parts of the crust where there are like these cavities, right? And these cavities in the crust are passageways for the mantle to get out. And why would the mantle want to get out? Let's play this game.
Pressure.
Yeah, pressure and temperature. Do that math. Pressure and temperature. What's going to happen as temperature increases? Pressure as temperature increases, pressure increases. So guess what? The mantle, which is hot, is pushing up on the crust with an enormous amount of pressure. Why? Because it's so darn hot, and when it's hot, those particles are moving really fast, and guess what? Sometimes these cracks can't hold the pressure, and it goes, and that's when you have a volcano. Now, these supervolcanoes are these giant calderas. The caldera is the pool of magma that directly feeds the volcano. And when you have these huge calderas under there, you have the capacity for catastrophic failure. Like, Neil Tyson, remember the modern day Carl Sagan? He said, he wrote a book, All the Ways the Universe is Trying to Kill You. And one of the things that he talks about in the book are these giant volcanoes, because if one of these things went off, it would be dinosaur-like extinction. Because you'd have so much ash in the air that the plants would die. If the plants die, the things that eat the plants die, and the things that eat the plants die. And then
I think they said the only
oceans.
thing that would survive would be a cockroach.
okay. Right.
Ew.
Good for them, right? Good
They
for
were
them.
survived.
And under the ocean. Don't forget the ocean. The
And
ocean's
the
probably
ocean.
gonna be cool. Because a lot of the life in the ocean doesn't need sunlight. Okay, yeah. Olivia?
That little thing you drew,
What little thing?
Like the big,
This?
that,
This?
yeah.
The caldera?
Yeah. Is that like hollow or what?
No. This is full of. This is
It's
full
like a
of rock.
cereal bowl. If you imagine
It's
like just a cereal bowl with the same bowl right on top of it, a perfect circle, that's the magma chamber. And then when it gets so hot, it's gotta go somewhere and
It's just like this.
heat rises, so it's gonna come
And it's
right through the
heating,
Earth's
right?
crust.
Heating. You get enough pressure going, right? You could like spew through the crust. So if I shook this hard enough, I could maybe get beans. I think there's beans in there
Or if-
coming through the paper.
If we had a can of pop that we
shook
didn't
it up.
open and shook it up,
That's
just
gonna
like if
increase
it
the
were a
pressure, too.
caldera with the increased pressure, open it up, boom,
Boom.
it's gonna explode.
So I have a question, so then how would like plants and like water just like come out, cause it's just like, cause like as you said, Earth was probably just one big melted like rock. Like,
Yeah.
how would like water just like form?
How would water form?
Yeah.
Groundwater?
Here, no, just regular water.
Yeah, like
Here-
how the ocean just like came to.
Now, Kramer, this is a great question.
So what is the question?
The question is, how, if Earth was a big molten rock, did water form? And here's your answer, Kramer, here's your answer. We were in class today, in chemistry class, and we came up with this equation. It was two octane plus 25 oxygen yields, I don't remember how many CO2, just 16, thank you, Skylar. And how many waters did we have?
2.
2?
We had 2.
Yeah. We have 36 H's, so we have to have
Just kidding, there's
18 waters. Okay. Okay, now.
I just remember seeing a 2, but it was that one.
Guys, this equation, you gotta follow me here. When you have something like this, an x is just a number, right? Because we're in a math class, we know what that means. Y is just a number. I'm not talking about like the element x, I'm talking about a number, right? If you have something like this plus oxygen, this, things with carbon and hydrogen, when mixed with oxygen, burn. This is called a combustion equation. And when things burn, what do you reproduce? Carbon dioxide and water.
Yeah.
Think about this.
Oh,
Where do you get the water from? You've got a flaming planet.
oh, that makes sense now.
Right? Now it makes sense, right? And this is the beauty of science, because you sit there and you're sitting there. If the Earth is this giant ball of molten rock, how do we get all the water? It's a good question. And the great thing about science is, bam, there's an easy answer. And it's like, of course, because when things are on fire, you produce water and carbon dioxide. And guess what? Guess where that carbon dioxide went? Because it didn't, when it went up into the atmosphere, it didn't just keep collecting. Because the amount of carbon dioxide, let's remember this, 80% of our atmosphere, nitrogen. 20% of our atmosphere, oxygen. But these are approximate, because that would add to 100, and that it's really like 19.9, but it's less than that. Let's just say 19. That's how much carbon dioxide is in our atmosphere. Not much. And you say, well, wait a second, because you're like, now I'm playing Kramer card. Hold on a second. You're telling me this whole Earth is a flaming ball of rock, and you're telling me there's combustion going on everywhere, and you're telling me while we're making all this water, we're also making all this CO2. Where the heck's that CO2 going?
Yeah, because then...
The answer? CO2 fixing bacteria. At the time, when the Earth was this molten and starting to calm down, there were bacteria. They took the CO2 and started, now there was something else involved, maybe some sort of sugar, I don't know the exact process for that, like it's not like cellular respiration, it's not like photosynthesis. They're taking the CO2 and they're fixing it and they're turning it into oxygen. And what started happening, all this CO2 from these CO2 fixing bacteria, they're called cyanobacteria, because they're blue in color, and cyan is a color of blue. Cyanobacteria started taking all this CO2 that was being produced and turned it into oxygen, and guess what happened? The oxygen levels went up, 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 and then guess what happened? With all this oxygen around, life started to develop that took advantage of the oxygen, like the aminals.
So that's my next question.
And another cool thing, depending on the number of plants you have, that depends on how much of this carbon dioxide is being utilized, right? Because if you're sitting around here, these are plants. If you have, thank you. Lots of plants means we're using
Lots of CO2.
lots of CO2,
And also
And
emitting oxygen.
making lots of oxygen. Love it.
So when we inhale nitrogen mainly and oxygen, but when we exhale, we're exhaling carbon dioxide. So that's why they always say, talk to your plants, talk to your plants, talk to your plants, because that carbon dioxide increases photosynthesis and actually makes your plant stronger and grow faster and live better. And then subsequently, the plant, when it takes in the carbon dioxide, releases oxygen.
I don't have the coefficients on this, right? C6H, okay, now we do. This is photosynthesis. Plants use water, well, you better water your plants, right? And CO2. And as Eric was saying, where can you get the CO2? Right? So if you talk to your plants, people may think you're crazy, but it's okay. You're giving them more carbon dioxide to move more food.
To create food.
And then it's also giving you more oxygen. So everybody wins. Now, back in the day, think it was once said that a squirrel could jump from the east coast to the west coast of this country without ever touching the ground. It would have to take the right path, but it could be done. And I will tell you right now, that is impossible. Drive through Indiana, and you know it's impossible. Drive through Iowa, you know it's even more impossible, right? Now, there used to be lots and lots of plants using lots of CO2, making lots of oxygen, right?
But
And now, there's fewer plants that are making less oxygen. Right now, the oxygen percentage is about 19%. Back in the day, the oxygen percentage was up around 24%. Now, certain animals breathe, not by way of lungs, but through their skin. Insects are one of these examples. They absorb oxygen through their skin. So, if you're an insect, just like when we talked about plants, the plants are absorbing the carbon dioxide through their skin, so to speak. If you're an insect, you're getting more food here than you're getting there. This is prehistory. This is about when the dinosaur extinction happened, which is about 65 million years ago, okay? If an insect was getting more oxygen, it would be able to grow more. Its cells could multiply. Dragonflies, 3.5-foot wings on each side. Dragonflies. Dragonflies alone are scary. But when you give that insect that extra oxygen, you have insects that are on scales that the Earth has never seen before. Now, what happened? Asteroid hits the Earth, dust gets bumped up into the air, blocks out the sun, plants die out, and here we are. But, to be sure, it used to be like this even whenever we first moved to this country in the 1640s. Plymouth Rock, you could go from one side to the other as a squirrel without touching the ground. Not anymore. So that number's going down even further. And guess what's going up as a result? The CO2 number, because you don't have the plants taking up the CO2. And what does CO2 do? Traps heat. It's like a blanket. So, less oxygen,
and then that
more
brings
CO2.
you into your global warming.
And movies like Prometheus are written.
Oh, nobody believes that.
Yes.
For the volcano?
Yes.
Like, how when the temperature goes up, then the pressure goes up?
Uh-huh.
Can you, would it be possible to add something to make the pressure go down so it wouldn't explode?
Well, if you think of Old Faithful, could you add something? Maybe, because there are chemical reactions where the amount of heat in the reaction goes down. There are chemical reactions like that where you can cool things down. The reaction that's occurring at the back of your refrigerator is such a reaction. It's taking heat away and cooling it down. Could you possibly take that technology and apply it to these calderas to make sure they don't blow up? Yes, you could. Would that be a mighty big project? Yes, here's why.
Yeah.
The crust now under the ocean, it gets thin to single-digit miles thin, but in normal circumstances, 25 to 50 miles thick. So you're gonna have to dig really, really, really far, and as you're digging, it's gonna get hotter and hotter and hotter to where whatever metal you're using to dig is probably going to start melting, because if the rocks are melted, your drill's probably going to melt too. You might just be up a creek. Now, does the pressure ever release in small amounts? Yes, Old Faithful, right? Just like if you have a boiling water on the stove and you get a little tss out the side, the pressure got too high, it needed to release. Old Faithful, the pressure's getting too high, it needs to release, so it just goes tss. And it lets out some pressure. When volcanoes erupt, like normal, good old-fashioned volcanoes, it's the same thing. There was too much pressure, and the pressure had to release. So what happened? A volcano erupts. And if one of these things goes, that
So
means...
how do we measure, can we predict if it's gonna erupt or not?
Yes.
we can try, yes.
The Richter scale.
Yeah.
So what we do is we put devices into the Earth that measure the movement of the Earth. And we can feel little micro vibrations, and then maybe there's slightly more than a micro vibration and slightly more to where you're getting a signature that says this thing's gonna blow. And what can you do? You can evacuate the people.
Can we like, cause you said there's pressure like in a volcano, or potentially in a weird way, like, if you know if it's like sliding in a room, can't you like, cause I know you said like, you could tell like big holes, like that probably would work.
Yeah, listen to Erica for a
See,
second.
we're at
She's-
Yellowstone. This is the terrain. Oh, lovely mountain. There's somebody up here exploring. Look how pretty it is. Birds. Okay, so now, that's a bird.
I love it.
So now here's your magma chamber. Obviously not in proportion. So you've got all this
Liquid rock.
all this liquid rock in here. Now, when there's a lot of movement in here, and those atoms start moving around and temperature goes up, what the way that they watch it at Yellowstone National Park is literally this flat terrain will begin to rise and move. And over here where there's a lake, say there's a lake over here, well, and you can Google all this. The lake is completely evaporated because it's so hot here that it is literally changing the geographic layout of this national park. So that is the way for them. They don't know whether or not, this is one of those super volcanoes. They don't know whether it's going to erupt tomorrow or 176,000 years from now, because these volcanoes are on a cycle. So they've seen a lot of activity, and there's plenty of YouTube videos that show these lakes just evaporating in minutes because the magma chambers
Great.
get super hot.
Just to show you an image,
Or how big it is. what you should-
what Erica's, oh shoot, come on. Isn't it called upthrust? Isn't that what it's
No,
called?
no, it's, go up front.
So pretty much we can die any moment.
Pretty much, I mean, it's, so you better get right.
Do you mean to show,
Get rid of that.
get rid of it? So what do you want to say?
Type in, I'm not good at that.
Okay, type in.
Type in supervolcano Yellowstone.
That's awesome. Tell your kid, guess what, son, you could die any moment. No, we can't die.
Son,
No, you
The
can't.
volcano just erupted, we've got about 5 minutes.
Goodbye.
Yeah, click this here. This is the blast radius.
So
This
much,
is where the caldera is right here. We're safe! The only thing we have to worry about is basically the fallout from blocking the sun out.
So this orange thing up here is the ash bed from Mount St. Helens. This is the proposed ash bed from the Yellowstone Plateau. This is the proposed ash bed from the Long Valley caldera. And this is the proposed ash bed from the Bishop ash bed.
Chambers that
It's down there.
CO2, because now you said like,
So,
What's that?
because now you said
Good old
like, CO2 is pretty helpful. Like,
I wish I could remember what it was called.
can we build like a CO2 chamber with like plants anyways?
That's what a greenhouse does. That's what a greenhouse does, because what happens is the sunlight shines
I
through
know, like,
and
a lot
the
of
glass
humans
traps the carbon dioxide in
So
it.
can we like use
Has he
the
really
magma
talked to
to
you about
like,
like greenhouse
make
gases?
things?
yeah,
Like-
like run-ons, like have it run-ons?
Okay, so let
Possibly,
me show
I
you
mean,
this.
we could just take the heat
Real
off of it
quick,
and trap the heat.
Kramer
Yeah.
had a question.
Check this out.
Okay, when it comes to environmental science, this is my life. I love it. Kramer, what was your question again, so they can hear?
Also, like, if you could build like, in case that does happen, couldn't you build like a little like a building that puts the plants in that's filled with CO2? Because how you said they get like stronger and they get better and like more oxygen is produced.
Right, and they could do something like that, except it would be
Really.
extremely expensive, and it may not even be as effective. But he had mentioned that you guys had went over global warming, greenhouse gases like methane. Okay, so here's the Earth, somewhat. Now, our ozone naturally repairs itself. This is ozone. Naturally repairs itself. So when the sunlight, that's over here, has rays that come in, it pops right back out. Well, with carbon dioxide and these denser chemicals, it's creating a barrier that's keeping the sunlight trapped inside of here, like a greenhouse effect. With the greenhouses are all made of glass, so when the sunlight goes inside the greenhouse, it stays hot in there, so the carbon dioxide levels go up, photosynthesis and respiration occur so plants can grow. Well, what are we now? We're living in a greenhouse because our atmosphere is so tainted.
Combustion produces CO2. What do we use combustion for? It runs our cars, it runs our trucks, it runs our houses. We heat our houses with it. What am I missing?